Hello and welcome back to Crash Course Trigonometry. This is episode 6. Today we will be learning about vectors. So what is a vector? A vector is basically an arrow. A vector quantity is a quantity that has both magnitude and direction. Now, in the past we've only used numbers that have magnitude, which they just have a value. Those are called scalar quantities. They only have a number, a magnitude, and they do not have any direction. So like the number 5, it's not 5 going anywhere, it's just 5. But vectors is 5 units going in a direction. A vector has magnitude and direction. The magnitude is always a scalar number, and the direction can be described by an arrow and the variable theta from the x-axis. So using theta, we can decipher the direction of the 5 units or whatever the scalar unit is. So, how do you add and subtract vectors? Well, I have an example up here, and I'm going to teach you 2 methods on how to do it. We have the graphing method and the component method. Let's start off. If a boat is heading northeast at 45 degrees for 12 miles, and the wind speed moves the boat 5 miles in the direction southeast, which is 315 degrees, find the actual path of the boat and how far it travels. Now, without vectors, you cannot do this. So the best way to start this problem is to figure out what our vectors are. And we have to figure out the direction and the magnitude of each vector. So first off, in the problem, we can see the boat is moving northeast for 12 miles. Northeast is our direction, 12 is our magnitude. So if we make a little compass rows north, south, east, west, we can see that our first vector, which I'm going to call vector A, is going 45 degrees for 12 miles. Our second vector is going 5 miles at 315 degrees. So we take this right here would be 315 degrees. And here's our vector, which I'm going to call vector B. And it goes for 5 miles, 5. So we have both our vectors. Now how do we add them together? Well, adding vectors, you put them tip to tip, what does that mean? You take the tip of one arrow and you put it to the tip of another. And you just do that as much as you want, as many vectors as you have. And you just keep adding them to their tips. And then at the end, you can figure out your resultant vector, which goes from the beginning tip to the final tip. So it would go from here to here. This was a bad example, but like over here, like if we added this vector and this vector, we'd get this vector right here. So first I'm going to show you the graphing method of figuring out your resultant vector from adding and subtracting vectors. So our first vector, we know 45 degrees for 12 miles. And our second vector went 5 miles at 315 degrees. So if we take a graph, we have this normal graph right here. It's an XY plane. It's also north, south, east, and west, just so we can figure out our direction better. So if we take our first vector and we start at the origin, and we go 12 units at 45 degrees, then that's our first vector. And then adding vectors, we start at the tip of the arrow, tip to tip, and we go and we draw our second vector. So we have our 12-mile vector and our 5-mile vector, vector A and vector B. So after that, we can use these vectors to find our resultant vector, which would be right here. This vector that is created would be vector A plus vector B. So that's how we find our resultant vector. But the question asked, what is the magnitude and what is the direction of this vector? And using the graph, we got lucky with this one. There happens to be a right angle right here. So we can figure out the magnitude of vector A plus vector B using the Pythagorean theorem. which is a squared plus b squared equals c squared. So in this case, a would be 5, b would be 12, and c would be a plus b. So we have 5 squared plus 12 squared equals c squared. And if you use algebra and you solve it down and you simplify it, you find that c equals 13. So 13 miles would be the magnitude of our boat. Our boat traveled 13 miles. Even though it only went 12, the wind blew it an extra mile and it went 13 miles right here. Now all we have to find is the direction the boat is going, and that's one of the harder parts because, you know, it's not a 45-degree angle anymore and we have to use trigonometry. So we have sine, cosine, and tangent that we can use. So if you take this right triangle, which I'm going to redraw really quick, 5, 12, 13, it makes it a lot simpler. We need to find this angle right here. So if we take the sine of this angle, which is opposite over adjacent, so katoa, sine of theta is opposite over hypotenuse, which is 5 over 12. And then we take the inverse sine of both sides, so sine -1 of 5/12 to get theta, which would equal, using our trusty calculator, we find that theta would equal about 24 degrees. Okay, so what does that mean? If we take this triangle and we translate it here, right here is 24 degrees. But we're trying to figure out if it's like north, east, south, west, whatever. So we need to figure out where it is from our x-axis, which happens to be east right here. So we know 24 is here, and we know this whole thing right here is 45 because that's our original angle. So if we take 45 degrees minus 24 degrees, we get our answer, which is 21 degrees. So in the end, we figure out the magnitude, or how far the boat is traveling, is 13 miles, and we figure out that it is going 21 degrees off of the east coast. So it's going 21 degrees northeast. North 21 degrees east, I believe is how it's said. And that is basically how you find the quantity of resultant vectors and adding vectors with the graphing method. You actually graph the vectors and then you just like use your triangles and all that and trig to figure out the missing pieces of what you need, and that's it. Next, we're going to move on to the component method of adding vectors. And I know I have a lot of triangles on the board right now, but it really isn't that bad. So say we have this one vector here. We don't know the vector, but we can split it into x and y, you know? So like say you have a normal line, it goes x and y, you know, it just like the slope of a line. And we can split this vector into two different vectors, vector I and vector j, with vector I being completely horizontal on the x-axis, or, you know, y equals any number, and j being totally vertical, x equals any number, y-axis, like that. So if we take our vectors from before, our 12 miles and our 5 miles, 45 degrees, 315, all that fun stuff, we can split those down into different components, and we can see that like there's an I1 and a J1, an I2 and a J2. And then once we split them into different components, we can just add those components together to get a whole new vector, which gives us like, you know, the actual components of our vector. This method is a little bit more complicated because you have to like you have to do multiple triangles, and like from here, like say we use this first triangle with the 12 and the 45, we have to do like sine of 45 equals j over 12, and then we find j, and then we find I, and then we do the same with 5 and find j and find I, and then add them together. But it is much more accurate, and you can find out the actual direction without using degrees. You can find the direction and the magnitude of your new vector much, much easier with the component method. Another thing with adding and subtracting vectors is subtracting vectors, but it's basically the exact same thing as adding vectors. It's just subtracting a vector is just making it negative. And a negative vector is the exact same thing as a positive vector, it's just in the opposite direction. So, if you have one vector right here, this is vector v, and you want negative vector v, that would be the exact same as vector v, just in the opposite direction. The magnitude stays exactly the same, the direction is just flipped 180, complete opposite. So if you're adding and subtracting vectors, like say you were adding vector v and negative vector v, it'd just be vector v and then negative vector v, and it'd equal a big fat 0. So like negative vectors and subtracting vectors, it's the exact same as adding vectors, but opposite, kind of. You know what I mean? I hope you know what I mean. If you don't, you can comment. I will try to help you as much as I can. The final thing I will be teaching you about vectors is how to multiply them by scalar quantities. As a reminder, scalar quantities are quantities that do not have direction. They are just numbers. So how do you multiply and divide scalars and vectors? It's really quite simple. You take the vector, you have the normal vector, and you just multiply the magnitudes. The direction does not change with any scalars because scalars don't have direction. Scalars do have magnitude. So you multiply the magnitude of the vector by the scalar you're multiplying it with to get your new vector. So here we have vector v, and it has a magnitude of 2 and a direction of 45 degrees. So if we want to find vector v multiplied by 3, it's just a vector with a magnitude of 6 going at 45 degrees. The direction stayed the same, the magnitude has changed. And vector v divided by 2, that is still the same right here, it just has a magnitude of 1. It goes 45 degrees with a magnitude of 1. The direction stays the same, the magnitude is multiplied and changed. It's very simple to do, and yeah, that's the end of our video. So I hope you understand vectors a little bit more now. If not, look it up in a textbook somewhere. I don't know. But yeah, thanks for watching, and I hope you have a wonderful day.